Number 7, childhood amnesia. You learn to walk, you learn to talk, you learned faces, voices, fear, and love. It's one of the most transformative and intense period of learning in your entire life, and you remember none of it. Science's simple explanation was that the hippocampus, the brain's memory center, was too immature to record anything, so the memories were never made. A shallow explanation that feels logically counterintuitive, considering those experiences literally shape who you become. In March 2025, Yale researchers scanned the brains of awake infants and found the hippocampus was actively encoding specific memories. The stronger the brain activity when a baby first saw an image, the more likely it recognized that image later. The memories were being made. The problem was never recording them. The problem is retrieving them. Those memories are likely still inside you, imprinted somewhere in the architecture of your brain. Your adult brain just cannot access them. We do not yet fully understand why. Maybe evolutionarily, we have no need to consciously recall them because they are already ingrained into your physical being and emotional wiring. But unlocking those memories could reframe how we understand trauma, early injury, and everything that shapes a person before they can speak. Number 6, contagious yawning. You just seen a person yawn, and there's a good chance you yawned right after, or at least a part of you felt the urge. This phenomenon of being triggered to yawn is extremely common because seeing, hearing, or even reading about a yawn makes you 6 times more likely to yawn yourself. It spreads through reading, hearing, and simply thinking about it. You don't have to be tired or bored to yawn. And we still don't fully understand this infectious behavior that has no negative side effects. The dominant theory was empathy. Mirror neurons see a yawn and automatically mimic it as an act of social bonding. But that theory has been repeatedly undermined since people with higher empathy scores do not yawn more contagiously. Another theory is that it enhances and maintains alertness because yawning often occurs when you're tired or during unstimulating activities. And yawning will recalibrate you back into a more attentive state of mind. The honest answer is that no single theory or hypothesis holds up. What makes this genuinely strange is that the behavior is ancient, deeply consistent across species, socially modulated, and completely unresolved. One of the simplest, most universal human experiences, and we still do not know what it is for. If you yawned while listening to this, congratulations, because I yawned at least 5 times researching this topic. Number 5, déjà vu. Around 2/3 of all people have experienced it. You walk into a new place, hear a conversation for the first time, and this confident sensation that you've been here before. Then a half second later, you have this confused feeling that it is impossible. Because you know you have never been here, that collision between a false familiarity signal and the part of your brain calling it out is what scientists call déjà vu. Neuroscientist Akira O'Connor found that during déjà vu, it is not the memory retrieval system that lights up most. It is the medial prefrontal cortex, the brain's error checking region, the part that monitors your memories for inaccuracies and raises a flag when something does not match. He came to the conclusion that déjà vu is not your memory malfunctioning, it is your brain's quality control working exactly as it should, catching a false signal and immediately rejecting it. The more frequently you experience déjà vu, the more actively your brain is fact checking itself in real time. So that intense familiarity is your brain believing for a second that it actually experienced it, but then your brain does a fact check to verify. But there's still a lot of mysteries that we don't fully understand. Because theoretically, you can trick your brain into a state of false recognition, making you genuinely believe you've experienced something that never actually happened. Number 4, inattentional blindness. Harvard researchers showed participants a video of people passing a basketball and asked them to count the passes. Midway through, a person in a full gorilla suit walks into the frame, beats their chest, and walks off. About half the participants said they never saw it, not because of poor eyesight, but because their attention was somewhere else. Scientists call this inattentional blindness, and it is one of the most unsettling findings in cognitive science. Your brain is not a camera recording everything equally, it is a spotlight. Whatever falls inside the beam gets processed in vivid detail. Everything outside it is simply not registered. The system evolved for efficiency. You cannot consciously process everything, so the brain filters aggressively and only delivers what it decides is relevant to your current task. The problem is that filter has no override switch. Radiologists miss tumors on scans while focused on another abnormality. Drivers fail to see cyclists they are looking directly at. It's a mystery that even with the enormous visual cortex evolution gave us, we can still miss literally what is in front of us. Number 3, the doorway effect. You are holding a thought, it could be a task or purpose. You walk through a doorway and enter the next room. The thought is gone. You go completely blank. And the more you chase it, the harder it is to remember. This is one of the most universally frustrating experiences that psychologists call the doorway effect. In 2011, psychologist Gabriel Radvansky confirmed that the brain does not store experience as one long continuous recording. It segments life into chapters, and a doorway is one of the most reliable chapter breaks it uses. When you cross a threshold, the brain files away everything from the previous context and opens a fresh page for the new room. That is an elegant evolutionary system for organizing memory across a lifetime. It is also the reason why you sometimes find yourself standing in the kitchen with absolutely no idea what you came in for. The fix is to walk back to where the thought originated, because returning to the original room reopens the chapter the brain just closed. I guess living in a studio apartment has its benefits. Number 2, time perception distortion. Think about the last class you did not want to be in, or the last mandatory meeting at work. For some reason, time moves slowly as if it was being dragged. Now think about the last time you were completely absorbed in something you loved or enjoyed. It could have been a 2-week vacation that felt like it flew by in days. Time is linear, meaning it moves forward at a constant rate. Yet these feel like two completely different realities. The mechanism is dopamine. When the brain finds something rewarding, it releases dopamine, and dopamine compresses subjective time. Your internal clock accelerates. Psychologist Mihaly Csikszentmihalyi called the extreme version flow a state of absorption so complete that time perception essentially stops. Fear works the opposite way. A study of first-time skydivers found that the more afraid the person was, the longer they estimated the jump lasted. Researchers at Harvard identified that time flies when you are having more fun than expected. Not just fun in general. The brain is comparing your experience against a predicted baseline, and the gap between the two distorts your clock. What this means practically is that your perception of how full or empty your life feels is partly a function of how much time you spend in dopamine-rich states. So the cheat code is to biologically hack yourself to enjoy what you fear, which should theoretically slow down your perception of time in whatever activity you enjoy and want to last longer. Number 1, dream amnesia. You wake from a wonderful dream. The first thing you do is try to remember it, but within 2 minutes, 50% of the content is gone. Within 10 minutes, 90% of the dream is gone. And this occurs every night. Scientists call this dream amnesia, a common phenomenon where 95% of dreams are forgotten almost immediately after waking up. And it is because during rapid eye movement sleep, the brain almost completely shuts off norepinephrine, the neurotransmitter that consolidates experiences into long term memory. Without it, the hippocampus cannot file dream content into storage. You are living a full sensory narrative with no recording mechanism running. A National Institutes of Health study identified a specific group of neurons that fires during REM sleep and actively sends blocking signals to the hippocampus, preventing memory formation mid dream. Evolutionary, it makes logical sense because if every dream were encoded similarly as a waking experience, your brain would lose the ability to distinguish real from imagined. Dream forgetting exists to protect reality. The one thing science has not answered is what the dreams are actually for. We erase them every night, so we can't truly study them. But we know there is something essential about dreams because evolution would have just discarded it. Thanks for watching. Like and subscribe to see more.